Hi, this is Ahmed again. We're going to start with chapter one. So, the chapter one of the textbook is the nature of mathematical economy. What do we mean by the nature of mathematical economy? The purpose of this course, Econ 3001, is to introduce the most fundamental aspects of the mathematical method, such as those matrix algebra, it's matrix algebra. Sorry. So, such as first one is matrix algebra. Also mathematical analysis. And optimization theory. So economics and mathematical economics, we know that economics is a social science that studies how to make a decision in face of a scarce resources. Specifically, it studies the individual's economic behavior and phenomena, and as well as how individual, such as consumer, like we have the consumer, and households, it's the same thing, household, and also firms, organization, you can name it, and government agencies. Make trade-off choices that allocate limited resources among competing users or competing uses. So mathematical economy is an approach to economic analysis in which the economists make use of mathematical symbols in the statement of the problem and also draw upon non-mathematical theorems to aid in a reasoning. So again, I'm just going to repeat this. We say that economics and mathematical economics, what is the difference? Now, economics is a social science that studies how to make decisions in face of a scarce resources. We have a limited resources, and therefore it is the study of how to make a decision in the face of these scarce resources. And specifically, it studies the individual's economic behavior and phenomena, as well as how individuals such as consumer, one person, or consumer, people who consume goods and services, and you can say a household, a family, and firms, organization, and government agencies, how they make a trade-off choices that allocate the limited resources among competing uses. In other hand, mathematical economics is an approach to economic analysis in which the economics or the economists make use, so in mathematical economy, the economist, so the economists make use of mathematical symbols in the statement of the problem and also draw upon non-mathematical theorems to aid in reasoning, to explaining the phenomena. Since mathematical economics economics is merely an approach to economic analysis, then it should not and does not different from the non-mathematical approach to economic analysis in any fundamental way. The difference between these two approaches in any fundamental way. So the difference between these two approaches is that the former, which is the economics with no math, the assumptions and conclusions are stated in mathematical symbol rather than the words in the equation, rather than sentences, so that the interdependent relationship among economic variables and resulting conclusion are more rigorous and concise by using mathematical models and mathematical statistics and economic methods. So in non-mathematical economics, or in other words, non-mathematical economics, they are using sentences to imply economic theorems and economic analysis. But mathematical economics, they are using symbols rather than words, and in an equation rather than sentences, that the interdependent relationship among economic variables and resulting conclusions are among rigorous and concise by using mathematical models and mathematical statistics and economic methods. Now, this will raise a very important question. And that important question is that what is the advantage of mathematical economy? So what is the advantage of mathematical approach? Mathematical approaches has the following advantages. One, it makes the language more precise. So it makes the language more precise, and the statement of an assumptions more clear. So the statement of assumptions more clear. And why? This can reduce many unnecessary debates resulting from inaccurate verbal language. So then with the symbols, you don't have to worry about all these verbal language inaccuracy. So the first advantage is that it makes that language more precise and the statement of assumptions more clear. And this will get rid of one of the fundamental problem with the verbal language and its interpretation. So that's number one. Number two, it makes the analytical logic more rigorous and clearly states the boundary and application. So it makes the analytical logic more rigorous, and clearly it states the boundary. Clearly it states the boundary and also applicable scopes. and condition for conclusion. So again, the second part is that it makes the analytical logic more rigorous and clearly states the boundary, and also applicable scope and condition for conclusions to hold. Otherwise, the abuse of a theory may occur. So if you don't have these condition, then the abuse of theory is very likely to happen. 3, mathematics can help obtain the result that cannot be essentially attained through intuition. So this is very important. Mathematics can help obtain the results that cannot be easily attained through intuition. And 4, this is very important. It helps. Number 4, it helps improve and it will extend the existing economic theory. So these are advantages of mathematical economy. Now, but it is, however, noteworthy, a good master of mathematics cannot guarantee to be a good economist. If you're very good in math, that does not guarantee that you should be a good economist. It also requires fully understanding the analytical framework and research methodologies of economics and having a good intuition and insight of the real economic environments and economics issues. So the study of economics not only calls for the understanding of some terms or concepts results from the perspective of mathematics, but more importantly, even when those are given by mathematical language or geometric figures, we need to get their economic meaning and the underlying profound economic thoughts and ideas. Thus, we should avoid being confused by the mathematical formula or symbols in the study of the economics. Now, in terms of scientific and analytic methods, we have 3-dimension and 6 nature. So we have, in terms of scientific, so we have a 3-dimension and we have 6 natures. Scientific economic analysis especially aim at studying and solving major practical problem affecting the overall situation is inseparable from a 3-dimension and a 6 nature. Three dimensions is the theoretical logic, practical knowledge, and historical perspective. So the three dimension are the theoretical logic, practical knowledge, and historical perspective. The six natures are it's the scientific, it should be rigorous, it should be realistic, it should be pertinent, it should be pertinent, forward-looking, and thought-provoking. Since social economic issues generally cannot be studied by only using real society and performing experiments on it, we need not only theoretical analysis with inherent and logical inferences, but also empirical quantitative analysis or tests with appropriate tools such as statistics and econometrics. However, only using theory and practices in insufficient and may cause short-sightedness, because the short-term optimum does not necessarily equate to a long-term optimum. As a consequence, we can say that the historical comparisons from a broad perspective are also requisite for gaining experience and drawing lessons. Indeed, only through the three dimension of a theoretical logic, practical knowledge, and historical perspective, we can guarantee that it is, or its conclusions or reform measures satisfies the sixth nature. Therefore, the three dimension and six natures are indispensable, means that they cannot be separated. So indeed, all knowledge is presented as history, all science is exhibited as logic, and all judgment is understood in the sense of statistics. As such, it is not surprising that mathematics and mathematical statistics or econometrics are used as a basic and, most importantly, analytical tools in every field of economics. Those of us who study economics and conduct research, it is necessary to grasp enough knowledge of mathematics and mathematical statistics. And it is for a great necessity to master sufficient mathematical knowledge if we want to learn economics well and conduct economic research and become a good economist. So all in all, to become a good economist, you need to be an original, creative, and academic way of thinking. So if you want to become a good economist, if you want to become a good economist, you need to be of original, creative, and academic way of thinking. So this is really important. This is the end of the chapter 1, which I want you to remember. And the most important of all of this is the difference between mathematical and non-mathematical economy. And what you really need to focus on that, what I said about mathematical as a review, the difference between economics and mathematical economics, that economics is a social science that studies how to make a decision in face of scarce resources, and specifically studies individuals' economic behavior and phenomena, as well as how individuals, such as consumer, households, firms, organizations, and government agencies make trade-off choices that allocate limited resources that we have among competing users. And on the other hand, mathematical economics is an approach to economic analysis in which the economists make use of mathematical symbols in the statement of the problem, and also draw upon non-mathematical theorems to aid in reasoning. And since mathematical economics is merely an approach to economic analysis, it should not and does not different from the non-mathematical approach to economic analysis in any fundamental way. So the difference between the two approaches is that the former, the assumption and conclusions are stated in mathematical symbol rather than words, and in equation rather than sentences, so that the interdependent relationship among the economic variables and resulting conclusions are more rigorous and concise by using mathematical methods, models, and mathematical statistics and econometric methods. So I talked about the advantages. This is another point which I would like, and then I would like to review it with you so that you know what these advantages are. The first one is that the advantage of mathematical approaches are that it makes the language more precise and the statement of the assumptions more clear, which can reduce many unnecessary debates resulting from inaccurate verbal language if you're using, like you're talking about national income. National income is Y, and that is equal to consumption plus have investment plus government expenditure plus net export. Imagine you're writing this as I say, okay, national income. And then you're writing everything else, and then now national income consisting of what? So this is what I mean, that if you're writing it, sometimes this could mean something different, where you have a symbol, you know that this is your growth level, or your GDP, or your national income, and then this is more clear and implies the meaning rather than by writing everything out, because then intuition in terms of linguistically translating it could be debatable. So that's why the advantage is that when you use a symbol, the language becomes more precise and the statement of the assumption is more clear. And again, this is more clear because now by writing it out in terms of sentences, this would reduce unnecessary debates which result from inaccurate verbal language. So that's number one. I think this is clear. And for the second part, which is two, is that it makes the analytical logic, it makes it more rigorous and clearly states the boundary. It will tell you what the boundaries are. Also, it's the applicable scopes, and the condition for conclusion to hold. If we don't have this, the abuse of a theory may occur. If you don't have the boundaries and we don't have the condition for the conclusions to hold, then so it will open a door for abuse of the theory. Number three is mathematics can help obtain the results that cannot be easily attained through intuition. Now, if you just write what is the growth level, if math is not involved and you say, okay, we have a growth which is a little bit more than last year, if you just write it in English, then it does not imply exactly that what do we mean by more than last year. Where if you use mathematics, you can say, okay, the growth in national income this year, or the GDP, was 2% last year, but this year we have a 4%. Now you can clearly see the difference, that actually the growth doubled rather than saying more than last year. So using mathematics can help obtain the results that cannot be easily attained if you're using intuitions. And last, not least, that's number four. Also, it helps improve and extends the existing economic theories. So that's for chapter one, and we're going to start with chapter two shortly in the next video.